So we're going to solve rational equations, identify extraneous roots. This is actually a complete review from Math 20, so on this before, we should feel comfortable solving these types of equations. So algebraically, to solve the equations, you want to state the non-permissible values. To do that, and before you talk about a lowest common denominator, you want to factor all x you can. Okay, and sometimes you should be able to factor and sometimes you won't be able to factor. So if it can be factored, you want to factor any parts of the equation. Multiply each sides or all terms by the lowest common denominator to eliminate the denominators. Solve by whatever means necessary, so isolating x or factoring. Check for extraneous roots. And then graphically, two possible ways to solve this. Set the left side to be y1, right side to be y2, and then solve for intersection. Or you could bring all terms to one side, set this as y1, and then solve for the x-intercepts, the zeros, or the roots. These all mean the same thing. So for example, if we look this first, I'm first going to talk about my non-permissible value, and my non-permissible value would be x cannot equal 0. My lowest common denominator would be x. So in all of these, I make these denominators x. So I wouldn't have to multiply this first fraction by anything because the denominator is already x. I'd have my second fraction by an x, and the third fraction I would not have to multiply by anything. And then so once we have the same denominator here, we can simply ignore those denominators and solve the equation. 6 plus 2x equals 10. Fairly straightforward. Move 6 to equation, divide by 2, x equals 2. So now I'm just going to cross-reference my solution with my non-permissible value. They're definitely different, so my solution would be x equals 2. Okay? My non-permissible value would be x cannot equal a negative 2. My lowest common denominator would be an x plus 2. So again, my first fraction already has that denominator. And I'll include the denominator one more time in this example, but after this we won't include the denominator. What's happening is we're removing that denominator. So the first fraction I wouldn't multiply by anything. The second fraction, x, I'd have to multiply an x plus 2 to get that denominator, and same with the minus 5. So now I'm going to ignore my denominators. I'm going to expand through expression here. Make my equation equal to 0, clean up my equation by collecting like terms, and now I'm ready to solve. So to solve this equation, I'd want to factor this, so we get an x and an x plus 1. Solve for x. Again, I'm now going to cross-reference my solutions with my non-permissible values, so both would be a solution to equation. All right, two more here. So for question C, before I talk about my non-permissible value, I'm going to factor out this denominator. I can factor out a 2 there, and all that does is it makes me identify it easier, because some might think that my LCD would be a 2x plus 5 at times a 4x plus 10, but once I factor a 2 out of here, I can clearly see that 2x plus 5s are common, and so I'd also just need my LCD to be this 2. So my non-permissible value would be x cannot equal a negative 5 over 2, and my LCD would be a 2 times a 2x plus 5. So I would have to multiply this whole first fraction by a 2. So 2 times x is 2x. Okay, I'd have to I should have shown this down here. The second fraction, I'm missing this entire denominator, so I'd have to multiply 2 and a 2x plus 5. So this is going to become a 2 times 2x, which is a 4x, and then I still need to multiply all of that by a 2x plus 5. And then this third fraction, my denominator is already there, so this isn't going to change at all. And so technically all of these fractions are over this denominator, but we know because they're all the same now, we don't need to write them out. So I'm going to expand this through my brackets. I'm going to end up with a quadratic equation again. I'm going to cut the equation. So this will be a negative 6x. Oh, sorry, this should be a 20x here. My apologies. So 22 minus 8 would be a 14x. And then we have a minus 15. And then we're going to go and factor that. So the factors of 8 and negative 15 using our lucky method, cross multiplying and dividing. A 4x. If I multiply that 4 by the factor of 5 here, I get 20. And then if I multiply the 2 by 3, I get 6. So 20 minus 6 gives me 14. So this needs to be a this should be plus, oh, sorry, this should be a negative 5 and a positive 3. So my solutions for x are x equals a positive thirds and a negative 3/4. Okay, just gonna double check. Sorry, this should be a plus, making here. 20 plus 2 is 22x. Positive 22x minus 8 would be a plus 18. So yes, this should have been a plus 5, which would be a negative 5/2. This should be a minus, which is a positive 3/4. So I'm going to cross-reference with my non-permissible value. Negative 5/2, no good. This is extraneous. So my solution would be x equals 3/4. All right. All right, so moving on to the last question. Again, my non-permissible value should be x cannot equal a 3/2, and my LCD should 3 minus 2x. So here's pretty straightforward. We have a fraction on either side of the equation, so we're just going to basically cross multiply there. I would have to multiply the x minus 1 by my denominator, so I get x squared minus 3x minus 7 equals a 3 minus 2x times x minus 1. I'm going to FOIL this out, so I get a 3x minus 3 minus 2x squared plus 2x. We're going to move everything to the left side of the equation just so that we're working with a positive x squared. So this works out to 3x squared minus 8x 4. So again, we're going to look to see to factor this. After spending about 15 seconds or so, I see that it cannot be factored. I have to resort to quadratic formula. So x equals plus or 8, right, and negative b plus or minus b squared minus 4ac. All divided by 2a. So we get a simplified value of 112 over 6. Break this down. A perfect square would be 16 times 7. The square root of 16 would be 4. Root 7 all over 6. And so all of my whole numbers can now be simplified by being divided by 2. So I'm left with 4 plus or minus 2 root 7 all over 3. Neither of these solutions is going to give me 3/2, so they would both be a solution to the equation. All right, and that is solving rational equations.